Hey guys, we're back. So let's go faster this time. This first one, number 5 here. Again, this is a two-termed factoring problem. So we are going to consider that this is probably a difference of squares. 81 is a perfect square. X to the fourth. Okay, yeah. X to the fourth is a perfect square. X squared times x squared is x to the fourth. And then there's a minus sign here. Good sign. And then this 1. And is 1 a perfect square? Yes. And that's where some people kind of messed up. Whenever we're factoring this, it's going to be two binomials. And I saw a couple people who had just like a single number inside the parentheses that they were multiplying by, and it was horrible. Well, it was not horrible. It was a big misunderstanding. So here we go. This is a difference of squares. Okay. All right. So equation now. So we said take the square root of the first number and the square root of the x term. So x to the fourth, the square root of that is x squared. So there's that. And then minus 1, because the square root of 1 is 1. And 9x squared plus 1. Now, who caught this one? 9x squared minus 1 is another difference of squares. And I think whenever I looked through all of the papers, I only saw 1 or 2 people that factored it all the way. So 9x squared plus 1, sum of squares, not a thing, right? But 9x squared minus 1, that can be factored again. So we're actually going to rewrite this here because convention says write it in descending order. So 9x squared plus 1, and then 9x squared minus 1 factors into 3x plus 1 and 3x minus 1. Okay, and so what I meant about descending order is that this has an x squared on it, and so it's the leader. It's the head honcho. It's the big one. So this is how conventionally we would write this. And I'm a little bit of a stick in the mud, and I like to follow the rules. So there you go. And I put too many parentheses in here as I say that I like rules. Okay, so that is the complete factorization of this one. There was 2 different squares hiding in it. So there you go. All right, next, actually, I'm just going to leave that right there and type here. So next, we see that all of these numbers are, again, even. And so that means that there's going to be a GCF of at least 2. And then after that, well, let's see. I mean, the GCF is going to be 2. And if I divide 2 from 4, I'm still left with a lead coefficient. So it's still going to be 2x squared, blah, 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 blah. And so that means that it's going to be an X box or grouping. And the reason that we know that is because the leader of the trinomial is not 1. The first thing we want to do is factor out our GCF, and that is 2. And then we are left with 2x squared minus x minus 6. And again, we are going to leave that 2 out in front, and then we are going to set up our parentheses for the final factorization. And so this 2 is that GCF, and it needs to be included. All right, so what are 2 numbers that multiply to be negative 12, because 2 times negative 6 is negative 12, and add to be negative 1, because that has an invisible coefficient of negative 1. All right, so 2 numbers that do that, that's going to be negative 4 and positive 3. Negative 4 and positive 3, because negative 4 plus 3 is negative 1. Yeah. And then you multiply them. Obviously, it's negative 12. So whenever we go to write this, it's going to be 2x squared And I would put the 4 next to that because 2 and 4 have something in common. So minus 4x plus 3x, and then the last term is minus 6. So there we go. And I'm just going to go ahead and start grouping this. Alrighty. And there we go. So 2x squared and negative 4x, obviously they have 2x in common. Dang nabbit. Okay, 2x. And then whenever we factor that out, we get x minus 2. And then there's a positive 3 as the leader. So plus, we can factor 3 out of both of these because 3 and 6 are both divisible by 3. And then we get x minus 2 because we divide each of these by that. All right. So there we go. We see it twice right at once, and we get x minus 2. And then slash those off, and we get 2x plus 3. And so that's the factorization of just the trinomial part. Remember, we have to include the GCF in our final answer. And so, again, since I like to do things pretty much by the book, conventionally speaking, we do put the one with the lead coefficient first, just because math nerds, mostly. But if you put it the other way, it wouldn't be incorrect. So this is the final factorization. Alrighty, let us back this up just a little bit. Okay, I'm going to scroll down so that you don't have to keep doing that. Number 7. This one is super duper simple. There are 3 terms. There's an x squared, there's an x, there's a constant. So this is just the x method. What 2 numbers that multiply to be positive 16 and add to be negative 8. Those 2 numbers are negative 4 and negative 4. That's a period instead of comma. You know what? I don't care. I'm going to save time on this one. So that means that my answer is x minus 4 times x minus 4. And again, conventionally speaking, this is not wrong, but the way you would see that written is x minus 4 quantity squared. And that is how we do it. All right, last one here. This one has A's and B's and numbers and stuff. Okay, great. 12 and 4 and 9 don't have anything in common at all. But there are A's that everybody has in common. There is not a B that everybody has in common. So we know for sure that this is going to be at least some kind of GCF. So let's figure out what kind of GCF this is. And so I can't take a number out. I can take A out. I can take actually an A squared out because that is the smallest coefficient on the A terms. I cannot take a B out because not everybody has a B. So, oopsie, there we go. We would have 12A squared, e to the 6 because the 6 is unchanged, plus 4, A squared divided by A squared cancels out, b to the 7th, minus 9, A squared divided by A squared again cancels out. Now, look at this. 12, 4, 9. Nothing I can do with that. There's still like more variables. And so this is not something that we can do X method or X box or anything like that. This is all it is. All right. See you back here for part 3.